right, everybody, here we are again. We're going to work on our percentages homework. So that's section 2.9 and 2.10. And before we begin, don't forget to give me a little summary and a check on how you're feeling after class today. Okay, now that you've gone ahead and given your summary and your check, let's start talking about our examples. Our first one is going to be a straight percentage problem. Where we do an is over of equals percent over 100. So remember, you can turn any percentage problem into a proportion by doing the is amount divided by the of amount, putting your percentage over 100. So for example, if we said what percent of 56 is 42, then you have your is amount, which is 42, that goes up here. Your of amount, which is 56, that goes down here. Percentage is what we're trying to find, so we're going to leave that as our variable, and then we're going to put our 100. So 42 over 56 equals percent over 100. Then you're going to cross multiply and solve, and you get 4,200 equals 56 times your percentage. Divide both sides by 56, and you end up with a percentage of 75 being your percentage amount. Pretty easy, right? It's just a proportion problem in disguise. Let's try another one. So again, it's a percentage problem. This one says 125% of what number is 17.5? So again, we have an is amount, which is going to be the 17.5. Of is what we're trying to find now. So that's the variable there. And we have our 125 to go in our percentage. So 17.5 over our of amount equals 125 over 100. Now remember, you're already dividing by 100, so you shouldn't need to change your percentage to a decimal. That turning it into a fraction over 100 makes your percentage without changing it to a decimal. Okay, so when we cross multiply this one, we get 1750 equals 125 times our of amount. Then we divide by 125 on both sides. And we get our of amount is going to be 14. Okay. All right, also in this section, we took a look at percent increase and decrease and relative error. So let's try one of those. This one's going to be a percent decrease problem. So it says a coat is on sale and the original price is $82. The sale price is $74.50. What percent off is it? And so remember that percent increase and decrease are not necessarily positive or negative numbers. In fact, they're all technically positive numbers, but the increase or decrease part comes from whether or not the amount went up or down that percentage. So in this case, since it's going on sale and the amount went down, whatever percent we find will be a positive percentage, but it will be a decrease because the price went down. All right, so if you remember, percent change is the change on top, the amount of change on top, and then your original price on the bottom. So here we're going to take $82 and subtract $74.50, put it over our original price of $82. That tells us the amount of money they took off divided by 82 will end up being approximately 0.09 or 9% change. Okay. So again, remember it's a positive value, but we're decreasing the price by 9% because it's on sale. All right, finally, let's do an error problem. So here they want us to find the greatest percent error in the area of a rectangle. And the rectangle is 7 meters by 8 meters measured to the nearest meter. And remember, that's going to be important. They need to know how or what measurement you were coming to so that you can base your estimates off of that. So if we're rounding to the nearest meter, then that means we can be off by half a meter. Remember, if you're rounding to a whole number, then from 0.5 up would round. So our measurements could be, so possible measurements could be up to half inch off. And that could be 7.5 meters by 8.5 meters. So it could be off by half a meter. So if I multiply and find the area of these possibles, 7.5 times 8.5, I end up getting 63.75 meters. Of course, our original area is 56, right? 7.7 times 8. So just like we did in percent change, our percent error is going to be the change divided by our original. So we could have been up to 63.75 and our original was 56. Divide that by 56 and you get about 0.138 or 14% error. So you could have been off up to 14%. Anytime you measure, everything's going to be a little bit off. And so this is a way of calculating how much off could you really and truly be. All right, guys, so let's do a little check on 2, 9, 2, 10, and we'll go ahead and put questions up and everything when I get back. Thanks.